Hello, and welcome to another of the Nautical Institute's technical webinars. My name is David Petraco with the Nautical Institute headquarters in London, and I'm being joined here on a very blustery morning by Robert, Edwin, and Dennis. Good morning, gentlemen.
Good morning.
Good. Now, before we start, just a few notes. I hope everybody's familiar with the Nautical Institute. We are an international professional body, and our main role is to help our members. Note that we are a membership organization, so if you're not a member, please join. We also work to represent our members' views and voices at various international and national fora, and that's pretty much what we're doing here today. We are an NGO at the IMO, and we are involved in discussing something called EEXI, which will be explained to you in very near terms. And we're trying to get your feedback so that we can better represent mariners on this debate of limiting engine power. The Nautical Institute, of course, is absolutely supportive of reducing greenhouse gases, but we want to make sure that we do that safe. And the reason we do all this sharing of information is to help everybody make better decisions. We think professional bodies, that's our main role, is to help people make better decisions. And obviously, issues around ship operations are key to what we do. Before we start, this is an interactive webinar, so you're most welcome to ask questions. However, your microphones and your cameras will not work. So if you want to ask a question, over in your little control panel, there is a box for questions. Type in your question. Please keep it as succinct as possible, and don't forget to press the send key. There are also a number of documents for download, including the slideshow that Edwin's going to give in a moment. The slides are very text heavy for the reason of recording. So please do download a copy of the slides so that you get all the information. We will also be running a poll at some point, and when that poll comes up, all you have to do is click on the answers you want, press submit, and that's it. So we're happy to share that with you. After the webinar, there'll be a little pop-up survey, so please do fill that out. It helps us improve our operations. About a couple hours after the webinar, and please wait till after the webinar, you will get an email saying thank you for attending, and in that email will be a link to a personalized certificate with your name on it. So you're very welcome to that. This webinar is being recorded, and the recording will be posted on the Nautical Institute's website in the My NI area, but please leave that till probably end of day tomorrow for us to get that edited and posted. You are not alone. There are nearly 600 people registered for this event, and so when you write in your questions, please keep them as succinct as possible, and we'll get to as many as we can. So off we go. Now, before we start the presentation, some of you will have noticed that we've been running a poll on LinkedIn and Twitter, asking people a very simplistic question, and most of you have been aware of that. If you need full power, and Edwin will talk about how power will be limited, but if you need full power, do you need it immediately, within 5 minutes, 30 minutes, or 60 minutes? And the results of that, after about 300 people voted, is most mariners overwhelmingly would like it immediately, with some being able to wait 5 minutes. But most people do not want to have to wait 30 or more minutes to get that full power in an emergency. And we can talk about that during the Q&A. So on that note, Edwin, I'd like to introduce Edwin Peng, who is a naval architect of 20 years, has lots of experience in, design, building, conversions. He focuses on safety issues. He's done research to inform the IMO and the EU He's the founder of the company Arcilia in 2018, and he now spends a lot of his time focused on reducing greenhouse gases and looking at energy efficiency. And he is here. We're very pleased to have him here. He is representing the Royal Institution of Naval Architects, and he does chair their committee at the IMO. So Edwin, please, the floor is yours.
Thank you, David, and thank you for letting me come and talk to you about this, and also a lot of appreciation to all who are listening in who are at sea and still very much part of the supply chain, keeping all of us fed and watered. So today. I'll do a short presentation, and then the idea is that we'll have lots of opportunity for Q&A. I will just do a very quick introduction to the Royal Institution in case some of you are not familiar. So RENA, as we're known, was founded in 1860 to advance the art and science of ship design, and we have members in 90 countries, and we've been an NGO at the IMO since 2001. And we have, like the Nautical Institute, a varied program of events and conferences in all these countries through divisions and branches. And the IMO committee of RENA is just one of 4 technical committees. You can see that up there, and they're supported by a publications committee. And crucially, we're made up of 30 volunteers who, with backgrounds, very varied backgrounds in ship design, shipping companies, class societies, consultants, and ship management. And we have 2 master mariners. And so crucially, it's 30 volunteers giving their time back to the industry that they've served for many, many years. And I'm very pleased to have Captain Dennis Barber here with me on the panel. So very quickly now into the meat of things, and don't worry that there's a lot of text. I don't intend to go through all of it, but some of it is useful for context. So why are we here with the EEXI? We agreed an initial GHG strategy at the IMO back in at MEPC 72 a couple of years back, and here are the 3 levels of ambition, and primarily it's levels of ambition 2 and 3, where we sort of say the IMO agreed that we need to reduce CO2 emissions per transport work as an average across international shipping by at least 40% in 2030 compared to 2008. What this means is that effectively we need to address existing ships as well as new ships. New ships is sort of level 1, and the 2 and 3 really deals with the bulk of existing ships, and that's the impetus, at least on the regulatory sense, for why we're having to do this. And so from there we came into the details at MEPC 75, so 3 sessions of MEPC after what we agreed earlier. We have 2 measures. One's a technical certification measure called EEXI for existing ships, which is really based on the EEDI framework for new ships, and more on that later, which broadly aims to bring design efficiency of existing ships on par with new ships. This is sort of quite important, and the requirements are set at the EEDI requirements in forces of 2023. Now, we also have an operational measure using a carbon intensity indicator, which is effectively fuel consumption divided by distance traveled and maximum deadweight, linked to annual improvement targets. In the past 3 months, the an IMO correspondence group has been tasked with developing 7 guidelines at very high speed and very short time for deliberations. But these 7 guidelines have been developed to help implement these 2 measures, and these will be further discussed and agreed at the IMO in May at ISWG 8 and further on in at MEPC 76 in June. Now, these broadly are now fairly well developed and fairly well advanced. EEXI is probably still a bit more mature because it is based on EEDI. So those of you who sort of know and are familiar with EEDI will sort of broadly understand what EEXI is going to bring. Now, I said earlier, before we go into the specifics of power limitation, we need to understand what EEDI and EEXI is and the sort of calculation specifics. Now, here's a very complicated equation of what the EEDI and the EEXI formula looks like. Don't worry about that. Look at this, which is the kind of simplification that takes out all the correction factors and complexities of that. And effectively, EEDI is 75% of your installed power times the carbon factor, which is a way of converting fuel into CO2 emission, which for HFO is 3.114 and for MGO is 3.206, so about 3, a factor of 3, and your SFOC of the main engine at that 75% point, which is also a NOx testing point, and auxiliary power, which is approximated for most ships at 5% of your installed power, again times carbon factor, and then the SFOC of an auxiliary engine or the genset at 50%, at the 50% load point. This is also in the NOx technical code and when you do NOx testing. In the denominator is deadweight, it's a fixed value, and then the speed is then linked to the point that we evaluate the power at. So speed at 75% MCR. Crucially, this is at maximum draft, i.e. summer load line. For some of you, that's Scantling. Calm water, no trim. So ideal conditions, really. And typically what happens for some ship types is that you conduct sea trials at delivery and ballast, and then you correct this to maximum draft using your tank test results. For other vessels, you can almost do your sea trials in full load. So this is a theoretical design condition. And this is very important. It's a theoretical design condition. It's a theoretical design point. So this is carried out at one time certification at new build. So the attained EEDI, as calculated by this formula, must be better than the required EEDI, which is set, and I'll explain where that comes from later. And EEXI follows the same concept. And just in case you're wondering about all these acronyms, EEDI is Energy Efficiency Design Index, and EEXI is Energy Efficiency Existing Ship Index. Just again to reiterate, this is a theoretical design point, one point in a very vast and varied operating profile that most ships will undergo. Just to make it simple, and you can debate, is this the right point? Is this the wrong point? But it's just really ultimately then a means of comparing and benchmarking different ships at a fixed, at a sort of fixed point with fixed assumptions. Now, where does the EEDI reference line come from? It comes from a regression of IHS fair play data of ships built between 1998 and 2008. And so here you see for bulk carriers greater than 400 GT, you see all these little blue dots. These are calculated data using something very similar to the EEDI formula of several thousand ships built in that 10-year period, and a regression line has been drawn through them. In this case, for bulk carriers, the regression is pretty good. So that black line is fairly representative of the population that we had at hand, with a bunch of assumptions. And this is the equation of that line. And all this is actually in Marple Annex 6, if you care to look it up. So having established this reference line, then EEDI and EEDI has these phases. So phase 1, if you build your ship, if you have a new building under phase 1, you need to be at least 10% better than your baseline. And if you build your ship within phase 2, which is from 2020 to 2025 for most ships, and for some ships it's from 2020 to 2022, then your ship has to be 20% better than that baseline. Note that once you've built that ship, typically under the EEDI, that's it. You don't have to keep ratcheting up and improving. Now, where this all changes is with EEXI. And so EEXI says, while EEDI has only been for new buildings since about 2013, EEXI says all existing ships that fall under a category of ship defined in Marple Annex 6 now need to comply with the EEDI requirements that are valid or in force in 2023. Now, this varies across the different ship types. So for bulk carriers, it's 20%. For cruise ships, it's 30%. For container ships, depending on the size that you are, it's again anything from sort of 30% to 55%. That's And there are some relaxations. There have been some relaxations for certain ship types or sizes where it was clear that actually the current or the EDI requirements would be far too stringent or unachievable for existing ships. Now, the EDI framework has broadly, and I say broadly, together with market forces and slow steaming actually, driven a gradual reduction in installed power in new ships. Now, this is a plot of the 75% power that we talked about earlier in the EDI calculation. We call it PME versus attained EDI for a bunch of Aframax vessels built broadly between 2011 to 2019. This is from the IMO EDI database, and you can sort of see there that EDI in these, which is on the x-axis, and power, which is on the y-axis. You can see slowly power reducing over these sort of three levels and these three groups, and EDI coming down gradually, almost in line with this power reduction. And that's sort of, this power reduction has led to some Aframaxes, or some Aframax designs going from sort of phase 2, meeting phase 2 EDI to meeting phase 3 EDI. Now, this whole issue of power reduction, it's important to then now make some distinctions. This, in EDI, this power reduction has been achieved mostly by engine derating. What this means is that you use 9 out of 10 cylinders in a two-stroke engine. Now, this is set at new build, so you effectively buy an engine with 10 cylinders, and the engine manufacturer adjusts it such that only 9 are in use, and this improves the SFOC of the engine. But also reduces the torque. So because you have less cylinders, it reduces the torque output of the engine. Now, with this derated engine with a better SFOC, you also have a lower RPM, and it's also enabled larger propellers. Now, you would have noticed that with larger propeller, you do actually need more torque. So these two things are in opposition in some ways. As we reduce the torque output of the engine, and you have larger propellers, there comes a point where you're maybe starved of torque. Now, all this started probably around 2011 and 2012. And here you see there's a plot of main engine RPM by delivery year for 50,000 ton deadweight tankers. And you sort of see that there's a very obvious point here where they started to entertain, this is post-financial crisis and just when bunker prices went through the roof, where the RPM drops quite dramatically. And this was in action. Now, as I said, this reduced power achieved through this method appears to have caused some issues with increased time passing through the barred speed range, which normally should be in seconds, and there have been reports where it takes sort of now minutes, and poor maneuvering characteristics, which I think some of you who submitted advanced questions have sort of asked about. And MAN, the engine manufacturer, issued a recommendation for increased light running margin in 2015 to address this for new ships. So it means that for ships that were built before this, or even after this, that didn't take this into account, you will probably experience some of these problems. The extent to which this has been fixed in existing ships, I'm not particularly sure about. But this is one possible explanation for some of the poor maneuvering characteristics that some of you have raised, and then is sort of known. I think some pilots also have talked about this. So yes, as I said earlier, so EEXI will enter into force in 2023. That much is, we are going to have the Marple Amendment agreed at MEPC 76. That is pretty certain. And all existing ships defined in Marple Annex 6. So earlier I mentioned talked about this, and these are bulk carriers, tankers, combination carriers, gas carriers, LNG carriers, container ships, general cargo ships, vehicle carriers, refrigerated cargo ships, ro-ro cargo, ro-ro passenger, and cruise ships. On international traffic, that's quite important. So domestic ships are not covered by this. And they must comply within the first annual intermediate or renewal survey. So to all intents and purposes, this is going to have all these ships will have to be recertified within a year of entry into force. So it's going to be a bit of a mad rush and mad scramble. And I think most class societies would recommend that you start investigating EEXI compliance now, because there's not going to be a lot of time if you need to make changes to engines. If you want to add energy saving devices and all that sort of stuff. So it is quite likely, particularly because of this time scale, that the effect of EEXI in existing ships will primarily be to drive a reduction in power rather than fitting of energy saving devices. And conceptually, the approach then is to reduce MCR, because PME, as we said earlier, is fixed at 75% of MCR. And it is suggested that the way we want to do this is via shaft or an engine power limit. Now, what do we mean by engine power limitation? So here you have an engine of about 8,600 kilowatts installed power. So the EDI calculation or EXI calculation point is 75% of MCR, which is this one, which is this line here. So I've color coded it together with the text. So that's your 75% point, which will give you something about 13.5 knots in calm water, I hesitate to add. And then to limit your power, you have this gray line, which is about 10%. This is now 90% of your installed power. So the limit is sort of 10%. You get this one, and then your new PME, basically your EDI or EXI calculation point, shifts to this sort of yellow line. So this yellow line here is now 75% of this limited MCR. So what you have then between 90% and 100% now is your power reserve. Now note, you're still able to operate all the way up to this gray line now. So you have this limited power. You have limited the power. You have a power reserve, which in normal circumstances is no longer available to you. But you can operate beyond the EDI or EXI calculation point. You can operate all the way up to this sort of limit. So that's important. So early investigations indicate that a wide range of limits will be applied. I've seen sort of power limits, anything from a handful of percent all the way up to about 40 odd percent. And it tends to be that the older the ship, particularly if you're built before the financial crisis in 2008, before the advent of slow steaming, you would probably have quite a lot of power. Container ships in particular, although most of them have already derated their engines, but certainly bulk carriers and tankers would have some higher power, which will now need to be dealt with under this regulation. Very crucially, what we're suggesting on this engine power limit is that this power limit that we impose can be overridden, meaning it's not a fixed limit, but in particular situations, emergencies and so on, you can release this limit so that this additional power reserve then becomes available to you. And that's also the background for one of the questions, the question that was asked in the LinkedIn poll. There were some questions, I think, which asked, so how much will speed be reduced by? So the imposition of power limits in EEXI doesn't automatically result in slowing down. This depends on the vessel type and the operating profile. Some vessel types are already operating far lower than even the 75% MCR point of the original 75% MCR point, or even less. So typically we hear stories about container ships perhaps operating about most of the time around 50% MCR. For bulkers, it might be slightly higher, it might be 60, it might be 70%. But it just depends on your trade, well, the charter, the contract you're under, and it's dependent on lots of different things. So that your mileage may vary, but effectively what all EEXI does is sort of it imposes a limit. There'll be a line. We could do a line randomly here, and that just means that this the speeds above this point are no longer available. But in the case this histogram is shifted to the left, then in many cases EEXI, whatever limit is imposed by EEXI will make no difference to your operating profile or to the speed that you normally operate at. So this is also this fairly important point. Okay, now the guidelines we have developed that have been developed foresee two main types of limits. There's a shaft power limit and there's an engine power limit. Shaft power limit particularly is if you have a typical ferry concept where you have two engines into a gearbox and then into a shaft, then it might make more sense to limit power on the shaft. Otherwise, it's with engine. And with engine power limits, obviously the more modern engines have electronic control, and so the means of limiting that will be different to the older mechanical engines. Now, this is a kind of engine load diagram on the shaft power and engine power limitation. So for shaft power limits and electronic engine power limits, you see this sort of cutoff as you increase your engine speed and your power. At some point, increasing engine speed no longer increases the power. And so you have this sort of hard limit, but all the time staying within the engine load diagram. So this is important. What we're doing here with this engine power limit is not to change your light running margin, is not to change your engine load diagram, but it's basically to snip off the top. So in a bollard pull case, so low speed maneuvering, these characteristics are preserved. This is very different from derating, where we lose one cylinder. Here we're just preventing you from putting more fuel into the engine, even though the speed goes up. So now with the mechanical EPL, it's slightly different because it's a limitation on the governor or the fuel rack, and so it's just controlling the amount of fuel entering the engine as you increase the engine speed, and at some point then there is a hard limit. I think there was a question on diesel-electric installations. Diesel-electric installations, particularly for cruise ships and LNG carriers with DFDE propulsion, you need to apply a limit on the pods of the shaft motors and not on the engines. So that's also fairly important. We have thought about this. The guidance will probably still need some finessing, and that is really the purpose of this webinar, to sort of get some feedback from all the experts out there about what works and what doesn't work and what we need to change. Now, very quickly now, just so that we have more time for Q&A, I have taken some extracts from the guidance just to highlight some key issues. For the shaft power limitation, you need sensors for measuring torque and rotational speed, and then data recording and processing device and a control unit. For engine power limits, it's slightly different. If you have a mechanically controlled engine, you have this mechanical stop screw and the governor. Here's kind of a picture and a sort of diagrammatic illustration of where this is going to sit, which will physically lock the fuel index, which the crew cannot release without permission from the ship's master or the officer in charge of the watch. For the electronically controlled engine, there'll be a fuel index limiter linked to a password, effectively, in the engine control system. And this is broadly how it's being conceived. There's probably more detail that needs to be developed, and how this will be implemented. Now, one other area where it's quite important to look at is the engine power limits today are used for compliance with right ship GHG rating for this EVDI thing. So if you've got an EVDI rating of E, and for chartering purposes, you want to sort of improve your charterability, if you like. Right ship also allowed engine power limits, but there are two crucial differences with the engine power limits we're going to use for EXI. So the EPL for right ship is permanent; it cannot be changed. It is not overridable. Whereas the EPL for EXI is overridable for the purpose of securing the safety of a ship or saving life at sea. And this is open to interpretation, obviously, as with Regulation 3.1 of Marple Annex 6. The other very critical difference is that for ships where there's an IMO mandated minimum power limit, that's for tankers, for bulk carriers and combination carriers, later right ship EPLs are not allowed to go below this minimum power limit because it's permanent, it cannot be changed, and therefore this minimum power limit that we've evaluated, you're not allowed to go below it. However, for EXI, the EPLs that we will impose in order to meet an EDI requirements will most likely go below the minimum power limit calculated for those ships. So it's just important to keep in mind the two categories of EPLs. One is, the ones that we have today are for right ship, they're slightly different, and the ones that we're going to have going forward for the purposes of compliance with the EXI are like this. Now, just to note, minimum power guidelines are under revision, but they're not thought to affect EXI compliance, since in any case, the limit can be overridden. but it may increase the MCR requirements for newer EDI ships. And depending on how it's calculated, minimum power limit actually most of the time is a torque limit, which is expressed as a power limit. Right. There's a few other extracts from the guidelines, which I think I won't go into in the interest of time, but they can be referred to as and when the questions come up in the Q&A. There are obviously reporting requirements and some general system requirements for what these systems should be able to do. And there has been mooted the concept of an onboard management manual for this, because it's important that the crew on board are very familiar with how this works in the case it needs to be released. Here we go. And if you use a power reserve, then there are logging requirements, which can be seen here. And the onboard management manual, as I said earlier, has some requirements for what should be in them. And crucially, that there's some information, it requests some information here about the time required for unlimiting the shaft power limit, and later on for the engine or the engine power limit. Same for this. And there's some information about verification of compliance. The final slide, estimating power and speed. Estimating the power and speed relationship for the purposes of EEXI compliance may be quite challenging due to patchy documentation available. So for old ships, and not being ageist here, but if you've got a ship older than 10 years old or 15 years old, the available documentation, particularly if it's changed hands a number of times, may be a little bit patchy. So trying to prove this relationship and the value of speed is maybe challenging, and the guidelines try to address this and give a number of options for how you might derive these values. However, trying to get a good set of PME and V relationship between, or a good value of speed and power, is quite critical for minimizing the required power reduction. So the worse your EEXI is to start with, the more you'll have to reduce power. Although critically, most of the time we think we'll be reducing power down to current EDI levels and not necessarily much below that. And then what we haven't touched and what we haven't spoken about here, but is possibly the elephant in the room, is the CII requirement. So as I said earlier, there were these two sets of requirements. EEXI is one, which is one-time certification. You also have these carbon intensity index requirements, which are currently still being discussed, but broadly will be agreed. And they may necessitate an annual reduction in average operational speeds. Now, this is operation. There will no longer this is no longer linked to some sort of device or password on the engine, but your vessel operator may then require you to slow down over time in order to meet these CII requirements. That's probably the subject of a separate webinar, but that's the end of the formal part of my presentation. I hand it back to David.
Thank you, Edwin. Right, Edwin, you've asked me to share a link to a YouTube video, which I have done. For those of you who are listening, it is in your chat box. Edwin, can you just explain why we've shared that?
Yes, well, I was doing some preparation for this last night, and some of you had sent in advanced questions. And this issue of low-speed maneuvering, I think from a number of pilots, came out a number of times. So this whole thing about reducing power, it really sort of depends on how you reduce power. And I think a lot of the explanation about the light running margin that is explained in this YouTube video from MAN is probably helpful for those of you who are trying to understand why maneuvering characteristics of certain ships is poor. And as I mentioned earlier in the presentation, it is linked to the fact that when we went for these D-rated engines, we went for larger propellers, a lot of these systems ended up being torque limited. So when you're maneuvering, the engine could not develop enough torque at those low revs and so the vessel is very slow to answer to the helm. Post 2015, when MAN updated the guidance, they increased the light running margin recommendation, and so all the ship designers in the shipyards ought to have updated their designs, i.e., they would have reduced the pitch in the propeller, and so that you would be able to have more torque at kind of low revs. I don't know the extent to which this guidance was followed. In theory, everyone should have done this, but then there remains this issue of those ships built in the interim, which didn't benefit from this guidance, which may be the ones suffering from poor maneuvering characteristics. But that YouTube video is designed to explain some of that in more detail than I could in this webinar.
Okay, thanks, Edwin. And also for those of you who are listening, just to remind you that Edwin's PowerPoint slides are available from the handout area. So there is a lot of material in there, so feel free to download those slides. Right, I would like to introduce the remainder of the panel. So gentlemen, Robert and Dennis, if you could uncloak yourself. Captain Robert McCabe is a long, illustrious career. Cii, he was the Director of Operations at the Commission for Irish Lights, done a lot of work with e-navigation. He's been a member of the Nautical Institute since he was a child. He has served just about every office in the Nautical Institute you can think of. He's been chairman of the technical committee. He's been a past president. He's now chairman of our IMO committee. And my gosh, I can't imagine what the Institute would be without him. Another stalwart of the industry is Captain Dennis Barber, also a fellow of the Nautical Institute and a fellow of the Royal Institution of Naval Architects. Started with tall ships, shipmaster, superintendent, been involved in risk assessments, accident investigators, expert witness, and he is now an advisor to that RENA IMO committee. Dennis, I can't imagine what you haven't done. Again, thank you in the best possible way, of course. So, thank you for joining this panel. Robert, I'm just going to run another little poll. It'll take about a minute, so if you could just introduce yourself a little bit more on what the Nautical Institute is doing this webinar for, we will carry on.
Okay, thanks, David. I can see the poll, so I'm hoping people can see me or can hear me at least. So as Edwin set out in his presentation, the IMO have set out important and challenging targets around carbon reduction and greenhouse gas reduction in shipping. And the Nautical Institute fully support those targets. We really do see sustainability in shipping as an important issue, and it's a very important issue for our members. So the objective of EEXI is to agree a methodology for reducing carbon emissions and from existing vessels, and to have a reliable means of monitoring that reduction. And that's probably easier said than done. And to get a system that works for all vessel types and all vessel sizes that led to that complex formula that you saw earlier. And thankfully, Edwin explained that in a more simple form. However, as is often the case, I think a critical part of what the Nautical Institute brings to these discussions is to try and translate that high science and those elegant formulas to ensure that they work in practice. And we do this in cooperation with a range of other NGO, and this morning we're here with RENA, but we also work with IMRS, with the Chamber of Shipping, and with many, many other NGOs to try and achieve this, and indeed with the national administrations. Because work at the IMO is always about cooperation. So as part of the EEDI and then the follow-up EEXI process, there was assumptions on weather and power requirements that at an early stage we felt were woefully inadequate for ships at sea. And ourselves and other NGOs were successful in having more realistic metrics applied. In the present discussions, I suppose what we've been looking at is making sure there's ready access to that reserve power. Now, we all know that in most situations, we'd be able to pre-plan this, and we'd be able to decide to lift the limitations on power and override them in advance. But there will undoubtedly be situations where a bridge team need access to that power, and they can't be going through complex approval processes to get it, because they need it fairly instantly. And that's more challenging, obviously, with the mechanical systems that Edwin described, as opposed to the more electronic systems where it may be just opening up a protective button and providing access to that extra power. We also looked at making sure the language is right. We don't want a situation where the bridge team are reluctant for any reason to access the power because they think there'll be a port state control issue in the next port or whatever. We don't want to go back to when I started at sea, which, as David suggested there, is almost 2 centuries ago by the sounds of it, where the officer of the watch was reluctant to use the telegraph. We want that language to be right so that people know that it is okay to use that power when it's needed. We looked at issues, practical issues around, people say password protected. Well, what if you can't find the password? There's got to be better ways than risking password protection. And to see how do we deal with that delay in removing the mechanical systems. We want to appreciation of the need to protect the seafarer, the people on board the ship, from loads more of administrative burden that often comes with these regulations. So we want to try and, as best we can, parallel it with ISM and with existing systems. And the implications then maybe in the next port, if you have activated the override, as to how you reset it. And that's fine in some ports, but in other ports you may not be able to get a representative of your administration or your recognized organization to witness that. And we want to make sure that those issues are understood. And as the most, finally, we also emphasize that the modern seafarer does believe in sustainable operation. And we underline the benefits of a positive approach, I suppose, that encourages seafarer innovation and sees the seafarer as part of the team trying to make shipping more sustainable. So EEXI is still under active consideration, but we're coming near the end of the process. And today is about hearing from people out in the field, people working these systems, as to whether we've got the balance right and what more we should be looking at. So I'm going to stop talking now because I think David's poll is probably coming to an end. And we do want to hear from participants on the chat box. Thank you.
Thanks, Robert. And I've shared the results of the poll. I'm not sure the speakers can see it. Fairly evenly spread. However, the biggest concern is heavy weather in coastal areas, which came in at 70%. Interesting, next is anchoring and breaking out of synchronous and parametric rolling. So I'll put those away. And just to remind people that hopefully we'll come to all of your questions, but this is about us collecting evidence. So if you have any questions or comments or statements that you'd like to submit to us on this issue, please put those in the question boxes and we will record all of these questions. So probably one for you, Edwin. This is Nicola saying, good morning. My question is, if we reduce power and consequently speed, that means a voyage will take longer to conclude, and of course meaning that the engine will stay on longer. Isn't that against the real objectives to reduce greenhouse gases?
Yes, thank you. There are probably two answers to that question. So one, as I said earlier, reducing the top end of the power in most cases isn't going to reduce your operating the speed of your operating profile. So I said most of the vessels in scope don't operate at speeds where EEXI will make a big difference. There will be some difference for some ship types, but it's not as bad as we think. So this really cuts off the top end, and you can in most cases operate normally. However, yes, so the other side of the equation or the answer is that where you do need to reduce speed, obviously some voyages will take longer, and so there is this idea that if a voyage takes longer, then you have more CO2. The very key thing to note there is your fuel consumption and the power of the engine is related to the speed cubed, and therefore the production of CO2 is related to the speed cubed. So as you reduce your speed slightly, even though you're going to take slightly longer to reach your destination, there is still a fuel saving to be had. This is also for those of you with long enough memories in the industry. This is what happened when we started slow steaming about 2011, 2012. This was the entire idea. Slowing down saved a huge amount of fuel, and that made the difference between sort of survival and going bankrupt for a number of companies where the fuel bill had become extortion.
Okay, thanks, Edwin. Dennis, I'm sorry, I introduced you and then I didn't give you a chance to say anything. Can you just explain your interest in this matter?
Yes, good morning, everybody, and thank you very much, David, for allowing me in. You may all be wondering what a Master Mariner is doing on the Royal Institution of Naval Architects IMO committee. Well, it's really a case, it goes back to when I was at sea, and I remember getting very frustrated about who designed this thing. And when I finally came ashore, they told me to put my money where my mouth was and go downstairs and talk to the naval architect. And I realized that I was going to have a lot of contact with these people because you see all the bad news when you're a superintendent. So I thought, well, if we can't beat them, join them. And so I joined them, and well, here I am. And that was 1980, and I'm still here now, and I'm on the IMO committee. So really, what I'm here to do is to represent you guys, because keep the thing realistic. So the driver does count, because at the end of the day, he's the one who crashes the thing. And so when I saw this, we've got a correspondence group working on this, who very wisely put it out to the wider committee. And I saw some of the things in here, and there's alarm bells rung. And I thought, well, we better, when they start talking about seafarers not being able to alter these things or cannot interfere with them, I thought, ding, 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 this is not good. There's something possibly that the Nautical Institute might be interested in here. And of course, they were already working on it. And so we decided to get our heads together. And so here I am now. I'm really sitting in, just in case Edwin wants me to jump in as a mariner's viewpoint. Thank you.
And thanks for all the support you've given us over the years, Dennis. It's been great. Dennis, we've got a query from Thornton, who I'll summarize it. Basically, he's saying, why can't mariners anticipate the need for speed? Why would you need an instant or a very short time period to get extra speed?
Well, my experience is, and it actually happened to me, in the piece I wrote for the run up to this, I found myself going into an anchorage, and it was somewhat crowded at the entrance to it, at any rate, with a very large ship. And I had a very strong tide. It wasn't bad weather. The weather was very good. The tide was extremely strong. And as I came to the point where I had to get into this anchorage, I needed to turn this ship, which is a Cape-size oboe, and it needed a lot of power to get this thing swinging around, so I could, to a point where I could drop the anchor without losing it. And it made me think. I thought, well, if I hadn't had that power, that would have been quite nasty, because just up the way, the tide was running me into water where there was not enough of it to keep my ship afloat. And I would have turned my contract into a salvage contract, and that wouldn't have been very popular with the owners. I didn't spot quite, coming into that, I didn't really see how much the turn was going to affect it. Now, all right, that's probably a fault on my part, but we're all fallible, and things happen, and you don't expect them to happen. Somebody does something on another ship that makes you want to do something quickly yourself. Really and truly, I realized then that instantaneity is something which really should be available to the master, and not be put your foot on the pedal. As you imagine being in your car, put on the pedal and find there's a brick underneath it, you wouldn't be too pleased.
Thanks, Dennis. Edwin, Robert touched on this a little bit. What is the bureaucracy, I suppose, behind unlimiting the power just in case? Or if you see that the weather forecast is building up, and you just want to make sure that that reserve power is ready at your disposal, even if you don't use it, what are the implications of unlocking that power?
It's a good question, and it's something probably that needs to be explored a little bit more in the text of the guidelines. So the guidelines, I think, mostly are around the lines of, well, you unlimit it and then you use it. But if you unlimit it, now, I mean, practically for electronically controlled engines, and if it's an engine power limit, then it's all been software driven, so it's very easy to reset it. even if you don't use it, I guess you could log it in a certain way so that it says you unlimited the power, but you didn't use it. For the mechanical one, where there's a physical seal, it's a bit less clear cut. So if you unlimit or you remove the seal and the screw as a precautionary measure, just in case, and then you have to put it back, even though you never use the power, how that'll be treated probably needs some clarity. So I think it would be very good for MEPC 76 that the Nautical Institute puts something into just investigating those scenarios.
Thanks very much, Edwin. And yes, we'll do that. And again, if I could remind people to send in their comments on these type of issues, because we are recording all the comments. I've got another question from Jonathan. He says, torque load programs have caused many issues with pilots, which is seen as not getting the power when required. Often this is not mentioned in MPEX, and there should be a master pilot exchange, and there should be an override of load programs in pilotage waters. Dennis, maybe you can touch on that?
Yeah, this is one fairly close to my heart. I've seen this happen as well. Although usually I've been standing watching, doing an audit on the bridge when on more modern ships than the ones I sailed on. It is very frustrating to push the lever up and realise that the thing is not going up very fast, and you need to get out of where you are. So yes, and you speak to the chief engineer. He says, "Well, the load program's in, and we can't override it, or we shouldn't override it." I've never been quite sure whether we could in an emergency, but always the risk has always been. My engineering colleagues have always told me of doing damage that would completely stop the engine, which is not what you want to do, obviously. So load programs, I think, is something which have crept in as they've reduced the weight and power of these engines. You suddenly find that they are actually not as strong as they used to be, and in the structural sense, and that I think is one that's crept in and needs to be watched. I sympathise with that position, and I've seen some very frustrating moments. Not as they haven't reached near miss situation, but you could see how they could. So yes, I'm very rather concerned about load programs, but that's slightly off the side of what we're doing at the moment. At the same time, it's important.
Okay, thanks, Dennis. And again, you in the audience, if you've had experience with that, please write into us so that we can document that. Edwin, question from Dirk. We have 4 main engines. Would using just 2 for sailing and 4 for maneuvering in port be acceptable?
Yeah, so I'm guessing it's a ferry, because this is the typical or fairly standard RoPax configuration: 4 main engines, 2 shafts into a gearbox. So for RoPaxes, it's a slightly more complicated state of affairs. What you would typically do, and so for those ships, if you're mostly running on 2 main engines at probably about 80%, 85% MCR most of the time, effectively you're using less than 50% of your installed power. And for the purposes of the EEXI calculation, you need to figure out how much limit is required, if at all, for that ship to comply. In most RoPaxes, I think we've seen that the power limitation that is required is relatively small, and so there shouldn't be much influence. So even if you do need to apply an engine power limit or a shaft power limit, it'd be of the order of sort of 5% or something. And so running with 4 engines is absolutely no problem. So you could still run 4 engines at 85% and still come in under the limit. So you should be okay. I don't know your specific ship, but I've done a fair bit of work on the ferry side, on the RoPax side, but that is the typical picture we're seeing.
Okay, thanks, Edwin. And Dennis, perhaps this one is for you, and it's from Risha's. And it says, in the wake of the new scenario, whether the charter party speed agreement also needs to be changed. How is the industry going to respond to this? So the charter party issue.
Oh, right. Yes, well, of course, we who've had to do the navigation and work out the numbers I've been very aware for many years that the charter party is the thing that drives everything, because you've got to meet the needs of what the charter, the customer, ultimate customer, is demanding. And I've been sitting in IMO for many years, and part of that time as part of the BIMCO team. The BIMCO, Baltic International Maritime Council, as you're probably aware, are key when it comes to charter parties. They have a big legal department who sit down and work out charter parties. They have been very involved with the EEDI discussion since it first came out. There's quite a lot of disagreement between the technical side and the legal side, but I can assure you that BIMCO, for one, and there'll be others as well, are watching it very carefully. And they are participating, as we are, in IMO. My bigger problem with IMO is I've been sitting there, as I said, for probably the best part of 30 years on and off, with different delegations and representations in NGOs. And what I tend to see is that there's lots of discussion going on, but it's mostly around legal issues, and rarely does the poor seafarer come into it, other than to be distrusted as can he be trusted to do this? And I spend a lot of my time, as I am now, saying yes, he can be trusted to hit the button if he needs to, and to reset it afterwards, because after all, the master has got to keep his fuel down. So because of why? Because it has been going on for many years. The charterer wants him to keep his fuel consumption down, which actually fits in rather nicely with this. So that is something which has been driving masters for many years. They aren't buoy racers, as we would say. They are people who have got to end the voyage and account for all the fuel they've used, together with the chief engineer, of course.
Okay,
thanks. Just to add to that, David, BIMCO have a working group looking at this issue of charter party, because the entire landscape is changing. When you have a long-term charter contract, or in many cases EEXI, and even more crucially CAI, is going to limit the speed at which you can go. And of course, there's a big problem, of course, with charter parties, where if you are mandated to target a particular CAI, the onus is on the owner and not the charterer. So BIMCO is working very hard actually on this, to introduce some new clauses to deal with this.
Okay, thanks very much, Edwin. I do have my eye on the time, and we're running out of it a bit. Robert, what are the next stages for the Nautical Institute? And if people have additional comments, how can they contribute?
Okay, thanks, David, and apologies, I dropped out of there. It's a stormy day in the west of Ireland, and internet's not the best. But next stages, I guess. Well, I'd always say the next stage, if you're not a member, join up. You know, that's the first stage. That means you get Seaways every month, and you keep abreast of these issues all the time. But no, we just finished our work through the correspondence group, and I think we've made some progress there. And today and other events like this have been helpful in identifying issues, which we will bring forward to MEP 76, and hopefully then the practical aspects of this will mesh well with the requirements, because as I said earlier, and I really don't want people to lose sight of this, modern seafarers and the Nautical Institute are advocates for this. We want to see sustainable shipping. It's by far the best way to transport goods around the world, and we want to see it sustainable. So we are advocates for it, and what we want to do is to make it work so that we avoid situations where the bridge team can't access the power. And the better we do that, the less of the situations will be where people have to override the system in preparation for some event that may not happen. The better the systems, the less that'll happen. So I'd encourage people maybe to link back to NIHQ and indeed to RENA on questions to have after today, because an hour is never enough. We could spend far more time on this, and just to thank people for participating today.
Thanks very much, Robert, and great plug for the Nautical Institute membership. But I'd also like to mention that RENA as well is a membership organization. And if you have interest in naval architect issues, they're a great organization. They're international. They do some very good publications, and please feel free to check them out. In the survey at the end of the webinar, there is a little tick box if you'd like to learn more about RENA, and there's a link to their website there as well. So just in wrapping up this webinar, I'd just like to mention, of course, thank you to everybody for your attendance and your great questions and your comments. We're doing this from headquarters. We also have branches all around the world, as does RENA. They have their own program of webinars, and if you go to the website of the Nautical Institute, you'll see where some of these other branches are and some of the events that they're doing. So please feel free to check that out. Another shameless plug for membership of the Nautical Institute and, of course, RENA as well. So, gentlemen, Edwin, Dennis, Robert, thank you so much for your time and participation and your support. We look forward to continuing a strong working relationship with RENA and working together to make it a safer and greener ocean. So I will invite you to say goodbye and to log off, and then I will close the webinar for everybody.
Thank you very much, David, and thank you
Thanks,
for
everyone.
listening all.
Thank you, and goodbye.
Bye.
Okay, bye.